Okay, so here's the next part of the interview, the coding challenge. I guess technically this isn't really a coding challenge, this is just a brain teaser. The idea is that there's a rabbit. There's a rabbit in a hole, and you need to find the rabbit in the hole. Here's the explanation. There's 100 holes in a line, and the rabbit is in one of those holes. So we're going to need to create a random position for that, right? That's pretty easy. Math.random, and we'll get between 1 and 100, or between 0 and 99. Now you need to guess and look in one hole at a time, and every time you look in a hole, the rabbit will move to an adjacent hole. So if the rabbit's in hole 50, it will move to either 51 or 49. If the rabbit's in hole 76, it'll move to either hole 77 or 75, and so on. And the rabbit's going to move back and forth. It'll always move one hole away from where it was previously, but we need to randomly determine whether that's a plus or minus one hole. All right, so I've got that understood. And then the idea is that you've got to figure out how to do this. And let's see, it says, good solution to find the right algorithm with the best O, like big O notation. In other words, the factor of how often, right? O of n, log O n, or O of n squared. Those kind of factors of how efficient is your algorithm. I don't know how efficient it is. When I first looked at this, as I listened along, I'm like, this is impossible. Or rather, it's not impossible, but it's not deterministic. My first thought was, well, it's like a game of hot and cold, right? If you start at 50, it's either at 50 or it's above 50 or below 50. And then you can work your way, right? Do you want to go 75, 25, and narrow it down, right? If you're playing higher or lower, or hot or cold, you can guess that, and that's a pretty good algorithm for narrowing it down. But the rabbit's moving every time. So I could go 50, 51, 52, 53, 54, up to 100, and if he's in none of those, well, he must be below. But he's also moving, and the trick is every time I look in a hole, the rabbit's going to move, either up or down, left or right, whatever, from one hole difference. So I'm not sure how to do that. My thoughts were at first, well, either pick hole number 50, and wait for the rabbit to show up in that hole, right? Eventually, he's going to, by some odds, right, he's going to eventually get to hole 50. But he might actually not. He might actually go back and forth between hole 76, 77, 76, 77, right? It could theoretically go plus, minus, plus, minus, plus, minus, and so on. So then my other thought was, well, if we randomly select, we've got a 1 in 100 chance. So statistically, I don't know the exact statistics, but if I guess, right, if you tell me pick a number between 1 and 100, and I guess 100 times, or 500 times, or 1,000 times, eventually I'm likely going to get it. It's possible that I will never guess it, just like it's possible that the rabbit will never cross hole 50. So those are two ways that might be semi-efficient, but are not deterministic, right? You're never guaranteed to get the rabbit. Best case is you get it fairly quickly. You're a good guesser. Worst case is you never get it, or there's a bad case, right? It could oscillate between 51 and 99 for several thousand tries, and then eventually cross the line at 50. So we don't want to do that. We want to try and narrow it down and kind of force the rabbit into a hole. And then as I was listening to them go through the discussion, they talked about how, well, what's the property of it moves? They talked about how if the rabbit's in hole 50 to start off, we'll say, right, the next hole it's going to be in is either 49 or 51. And then the possibilities after that, well, if it's in 49, it's going to be in 48 or 50. If it's in 51, it's going to be in 50 or 52. And seeing a pattern here that it's always going to alternate between an even and an odd number, right? If it was on even, it's going to go one different, and it's going to go to an odd numbered hole. if the rabbit was an odd numbered hole, it's going to plus or minus 1 go to an even numbered hole. And I got to thinking, and I paused it when they got to that point and tried to solve it myself. And I'm going to walk through my solution and see how it is, and see what we can get, right? So first thing I need to do, I got to the point where Dan says, let me write a test harness for this. And I was like, oh, a test harness. I'm a tester. Let's go ahead and explore that idea. So without further ado, let's check it out. So I'm going to open up my code editor, and I'm just going to create a new file, right? And I'm going to call it down the rabbit hole .js, and we're using JavaScript. Let's get rid of this getting started, right? So down the rabbit hole. I always start off with kind of a sanity check, right? I can run this and it prints down the rabbit hole. Excellent. I don't know if I'll actually need the terminal. I'll just use the terminal output for Visual Studio Code. I usually flip back and forth, right? I might I go node down the rabbit hole. Same thing without a little bit of this running. So let's see. The first thing I need is I'm going to need to create a random number generator, right? So I can pick the rabbit, right? So I need to pick that the rabbit is in some hole, right? Rabbit equals some random hole. And I need to go between 1 and 100. So that's math.random, right? I think this is going to generate a number between 0 and 1, like some weird floating point number. Run this. All right, yeah, so we'll just run this a bunch of times and see just to make sure. All right, so we got 0.1, so that's like 10, 25, 18, 96. Just trying to make sure we've got sanity 57. Okay, I'm pretty sure that's what it does. Random number generators often do between 0 and 1, some random floating point number. So what I need to do is I need to do like 100 times that. And now I've got 95, I've got 95 again. What are the odds of that? I must have done something wrong. 98, 34, 66. Okay, so it looks like I've got a pretty good spread, right? If I were to do this, fingers are getting cold. All right, if I run this 100 times, I just want to make sure that my random number generator looks fairly accurate. It doesn't have to be perfectly random. Here, we'll go over here. All right, let's see, 74, 97, 97. Man, what are the odds of it getting something? So there's so many repeats. I question the randomness of this, but it's probably okay, right? It doesn't have to be perfectly random. But we've got a big spread. We've got between 0 and what's our highest we see here? I don't see a 99. I'm going to call this good enough. What I could do is, right, I could collect these and analyze, right, run 100,000 and make sure. The other thing I want to do is I want whole numbers, right? So I'm going to do math.floor, which just rounds down, right? It'll drop the decimal. What's the clear console? I thought there was a button for that. Is that clear console? Yeah, that is. Okay. So if I run this, Yeah, so I've got a good set of numbers. I've got zeros, I've got 79, 97. That looks good enough for now. All right. So we've got a function to put the rabbit in its place, right? And as a matter of fact, what I'm going to do is I'm going to create a function. I'm going to call it, I want my own random function, and I want a number, right? And what I'm going to do is I'm just going to do this whole line here, and number times math.random, and then I can do rabbit equals random. That'll be between 0 and 99, or 1 and 100. Oh, kill that off. Undefined. Oh, we've got a return. All right, so yeah, that looks good to me. 68, 38, 83, 82, 50. Sequential numbers or duplicate numbers, I don't know, maybe it's taking the second or whatever is the seed. 25, 80, 0. Okay, so that looks good. We've got a random number generator. We've got a rabbit in a hole, some hole between 1 and 100. Next thing we need to do is we need to make the rabbit move, right? So function move. Now we could pass the rabbit to this, but what I'm actually going to do, I'm going to use a closure, or I hate the term closure, because really all this is this is an outer lexical scope, right? So this program, this file, this module, whatever it is, has its own scope, right? So rabbit is a global var within the scope of this program, this down the rabbit hole.js, right? If it was in another file, it'd be in a different scope. If it was running on a different JavaScript VM, I was going to say JVM. If it's running in a separate node instance, or separate browser window, whatever, it's going to have its own scope, lexical scope. Variables in one browser window don't affect variables in another browser window, and so forth. Variables in one program don't affect variables in another program. So this is my outer scope, and it's fine for this simple program. So my rabbit is in the outer scope, but in JavaScript, a function has its own scope too, and the function scope inherits the outer scope, and they call that a closure. That's not everything that's in a closure, but that's the main thing of a closure, is a function that's inside of another function has access to the outer function's state, its scope. So what I can do is I can move my rabbit, right? And what I want to do is I just want to do rabbit plus equals 1, right? Or rabbit plus plus. And then what I can do is I can do for I less than 100. We don't actually need to do 100 of these. I just wanted to, what I want to do is I want to move rabbit, or I'm just going to move, right? What I could do is I could say rabbit equals move rabbit, and then return rabbit. And now I don't have an outer scope. Maybe I should do that just for code cleanliness, so that I don't have this global variable. But nah, I've already committed to using my outer scope. So I'm just going to move, and then I'm going to log my rabbit's position. right? Okay, so that's what I'm going to do next. We'll close that off. I think I like doing it over here. All right, so my rabbit's not moving. He starts at 31. So I'm going to, the rabbit is in whole number. So I use this string formatter to print rabbit. All right, I've got an issue. The rabbit is in whole rabbit number rabbit. What does it say? Rabbit is not defined. Do I have a typo? Function is not defined. So it should hoist this random function, I believe. Is it not doing that? Or does it hoist the variable above? And why did it work here and not there? The world will never know. So we're at 32 over and over. I'll add my semicolons. Maybe that'll magically make it work. Let's just move this 10 so that we can see it better. Oh, we're passing rabbit here and we don't want to do that. There we go. So you can see the rabbit moves up one, 76, 77, 78, on down. So we needed to move either up or down, or right or left, right, add or subtract. So what I'm going to do is I'm going to create another function, right? I think I can move that function back below my rabbit declaration. I guess it doesn't matter. I just need, yeah, it's going to hoist my rabbit anyway. Right, it's going to move that variable rabbit to the top of here. Nope, it's not going to do that. And that, ladies and gentlemen, is why let is a thing. Because the scoping of variable declarations is not intuitive. All right, we clean up. So we've got a random function. We're using it to pick a random hole for our rabbit. And then we've got our move function to move our rabbit, and we're trying to move our rabbit. But we want to move up or down, so or left or right. So I'm going to make a function, and I'm going to call it left or right. All right, we're going to randomly move left or right. We're going to flip our coin and go left or right, up or down, whatever. To the left or the right makes more sense, right? We're going down the rabbit hole. The rabbit's going to the left hole or the right hole, or vice versa, whatever the screen is. Okay. Left or right. So we'll do direction equals random 2. And so I think I'm going to hop into Node here and copy my random function. When I do random 2, it's going to be 0 or 1, right? Yeah, 0 or 1. Okay, it's not exactly regular, but look at that long streak of zeros. So my random function is going to be 0 or 1. What I want to do is I want to say, if it's 0, make it -1. If it's 1, +1. Right? So let's think about that. So what I want to do is I want to say, if it's true, If it's 1, I want to go +1. If it's false, I want to go -1. So I guess I can just return random to left or right. Let's test this out as well. So now we've got function left or right, and now I can go left or right. -1, 1, -1, 1, -1, 1, -1, 1, 1. Okay, so it's not completely flipping back and forth. So it'll randomly, it'll randomly go +1 or -1 to the holes. So now I can move my rabbit, right? Where is my move function? I want to do rabbit equals left or right. Plus equals left or right. Instead of plussing 1, we're going to +1 or -1. And plussing a minus is a minus, right? So we're going to move left or right. Let's test this out. I'll bring my move function over here. Where's my rabbit? Rabbit is not defined. Let's go ahead and we'll bring everything into node. I like using the REPL. Okay, so my rabbit starts in hole 20, right? And then I want to move left or right. So I think I need to copy. I'll just copy both of these functions over here again, right? All right, so rabbit is in hole 20. And I want to move left or right. Rabbit's in 21. I want to move left or right. Rabbit's in 20. Okay, so he moved up, then he moved down, and then he moved up again. And then he moved down again. He moved up again. Down again. All right. I don't like this. It's alternating. My random number, oh, look, it's at 19. He's at 18. Okay, so, oops. Okay, so he is moving it. Seems to defy the odds. He's moving up or down. Looks 17, 16, 16, 17, 16, 17, 16, 15, 14. So he's moving slowly one way or the other, right? And there's that oscillating back and forth. What if he flips between 16 and 17 a whole bunch and I'm waiting at 50 for him? Or what if I guess 17 and he's at 16 and then he moves to 17 and I move down? I've got to take that into account. Well, first I need to check, right? I need to check if the rabbit's in a hole. And yeah, this will help me to read it. But I'm going to move my function. These are all single line functions, so I'm going to move on to a single line just so I can read more on the screen at once. All right, so I've got my random function, my left or right function, which makes use of random. My start, all right, I'm starting my rabbit at some position, and I'm moving my rabbit. And this down here, right? So move, because I'm using this outer variable rabbit, it needs to be below that in order for this outer scoped variable rabbit to be referenced within the move function. The more I look at this, the more I'm thinking it might be nice to pass the rabbit and return his new position. So I do var rabbit equals move rabbit. Whatever. All right, so I'm still not going to worry about that. This is where I'm doing my work, right? So our rabbit's going to move 10 times, and now I can do node down the rabbit hole. Oops, I need to exit out of here. All right, down the rabbit hole. The rabbit is in hole 10. He goes 9878, 765, 434. So in this case, he's tending towards 0, but that might not necessarily be the case, right? Let's go through this. So he starts in 81. He oscillates, goes to 69. What I'm trying to do is I'm trying to come up with a scenario which will show an edge case here, which is what if it goes, what if he goes beyond hole 99? We don't want that to happen, so we need to check, right? So in our move function, this is going to be more complex actually. So he's going to move left or right, and then what we want to say is if the rabbit is in hole 0, is less than 0, so he bumps up against our first hole. I gotta fix that mirroring of the screen. If he tries to go past hole 0, we're gonna bump him up. He's gonna hit hole 0. He's gonna hit the wall and go to hole 1. So rabbit equals 1, right? And then same thing, if rabbit is greater than 99, we want our rabbit to go to pop back down to 98. All right, we've got a mistake here. Well, let's read the error. If a rabble, not rabbit. I must have auto-corrected it for me. All right. Yeah, let's not look at it in there because then we can't see our code. No, down the rabbit hole. Okay. Did we bump up against any edges here? We're staying in the 40s, 30s, 50s. All right. 9999. Did we never once get to 0 in 1,000 tries? And we never once got to 99. That's incredible. What if we start off our rabbit at hole 99 just to test it out? So 98, 99, I guess that doesn't guarantee it. So we bumped up against either it never actually hit 100, or we could do something like this. Bump. Bump left and bump right, right? If the right side is 99 and the left side is 1. So now I'll see if it ever bumps. Here we go. So we started at 99. We bumped left. We bumped left a couple times. All right, so we're good here. So we can see that you could end up, here we've got a few bumps. Bump rights. In 1,000 tries, it's only bumping up against the wall a couple times. So it's going to be tricky to catch him, right? Because he can go back and forth. We see it's going between 13, 14, 15 for a long time. So staying in one spot is not going to work very well, right? It could take forever for it to actually guess that number, theoretically. We've got cases where it could take more than 1,000 tries to hit the edge. Whew, I'm cold. I got to take a quick break. Add some wood to the fire. Crank up the fan. Okay, so we're starting to get a test harness. It looks like we've got a rabbit. He starts in a random hole, and he moves left or right. If he goes beyond the first hole or last hole, we bump him back the other way. So I think we've got everything we need to make the rabbit function. I may be missing something, but we still haven't got a guess, right? So let's try. What we want to do is we want to check where we're at, right? Let's also add a little comment here. The rabbit moved to hole number there. Just a little bit of output. So the rabbit moved. And what do we want to do next? We want to look in the hole, right? So I'm going to create a function look. And what we're going to do is we're going to compare, right? So we're going to look in a hole. And then we're going to guess, right? So if the rabbit is if the rabbit equals the hole, then we're going to console.log you found the rabbit, and then we'll exit, right? We'll return to. And then else we'll we'll just say wrong and return false. I like to actually do my negative cases first, and then actually have my success at the bottom, because then, right, this is like indicating a failure. Indicate all your failures, all your edge cases, and then do your happy path. I'm having trouble with the way this is highlighting the code. Okay, so we're looking in a hole. We want to do if the rabbit is not in the hole. Did I say that at first? If the rabbit is not in the hole, right, wrong. Let's try something better. The rabbit is not in hole number hole. We need to change our quotes to backticks for that interpolation, and it looks like we need to fix that also. All right, the rabbit is not in hole number, whatever hole we guessed, right? Yeah, and that's more likely to happen. Anyway, I guess it might actually make sense to break out, right? Because finding the rabbit is actually the exception case. Yeah, let's do that. No. Because I like to return false until returned, right? It's like it's like a search algorithm. Literally a search algorithm. We're looking for a rabbit in a hole, and if the rabbit's not in the hole, we want to return false. So rather than check if he is in the hole and return true, we'll return false first. I don't know how much it really matters, but that's just the pattern I have in. Is all your not cases happen first, and then your true case or whatever happens at the end outside of a if statement block or in an else statement, right? It doesn't need to be outside, but that prevents double nesting of conditional blocks. All right, so let's take a look at this. We want to look in the hole. So what we want to do is we want to look in the hole, and then we want him to move. Now, I guess what I want to do is I want to var. It's not working here. Var. I don't know what's going on here. Var. Found equals looking all right. So we're returning true if he's found, and we want to look in a hole. And we want to look 1 to 100. And then we want to move if he's not found. If he is found, well, then we'll just break, right? If found, break. And see, this is kind of suffocate. And then we continue with the move. The rabbit has moved to whatever. All right, let's run this and see. We're obviously not done yet, but we found the rabbit. The rabbit started in hole 2. We guessed 0. The rabbit moved to hole 1, and we found the rabbit. We should probably, you found the rabbit in hole number, hole. But right, that's like a fluke. What if he starts in 99? So here we went through 100 cycles, right? The whole rabbit started in hole 79. He's not in hole 0. He's not in hole 1. And he kept going. And we went through all the way up. How did he move? So we missed him somehow. So it says, the rabbit is not in hole 71, but then the rabbit moved to hole. So we looked in hole 71. The rabbit was in hole 72, so we missed him. Then we went up to 72, and he went down to 71. So we've got to catch that. And this is the part where this was my aha moment. We said, well, it's going to be odd or even, right? Well, if it's going to be odd or even, then, and it's going to switch every time, what can we do? Well, I can be even twice in a row and then odd twice in a row. So here's the trick, right? What I want to do is I want to look twice in a row on the same number, right? So what I want to do is I want to look in hole number 1. If he's in hole number 2, I want to look in hole number 1 again, because then if he moves to hole number 1, I've got him. If he moves to hole 3, well, he's got away, and I've got to chase him down. But he'll never pass me again, right? So that's what I want to do. Is I want to. So I look at a hole, and he moves. And probably what should happen is every time I look in a hole, I move. So this move should happen in look, right? So if the rabbit, again, we've got to go back here and do this. I actually want to do it the other way. So again, it doesn't matter, but this is going to make the logic make more sense. So if the rabbit is in the hole, not in the hole, this is how bugs happen, is cut and paste. 90% of bugs happen from cut and paste errors. The other 90% happen because I don't know what I'm doing, right? So if the rabbit is in the hole, return true. Otherwise, say the rabbit moved to whatever and return false. So now every time I look, by looking in a hole, I spook the rabbit and he moves to another hole. And now my loop doesn't have to move the rabbit every time, right? So I look, and if found, break. And let's just do this here. right? Do I need to do that twice? And then, well, let's see. See if this works. So theoretically, it's going to go through each hole, right? Start at 0, go up to 100 or 99, and it's going to look in each hole twice, and it's going to look in a hole the first time. If the rabbit's in the hole next to my hole, then he's going to move either away from me or towards me. So the second time I'm going to look. If he moves into the same hole, yeah, I think this is it. And I found the rabbit in hole 32. So you can see the rabbit moved to hole. I guess what I want to do is here I want to do console log. The rabbit is not in. Right, I just I want an output to check. I need to learn to use cut and paste. Get rid of that. All right, so I'm going to say you look in hole number. All right, so that's just going to give me a little bit more debug output. Did I hit save on that? I did. All right, so the rabbit's in hole 25. I looked in hole number, no, I looked in hole number, hole. Why didn't I find him then? Okay, so it starts off down the rabbit hole. The rabbit is in hole 88. I looked in 0. I looked in 0 again. Obviously, this is not optimal, but maybe this is the best case. This is the best case I can think of, is I start in hole 0 and I search, right, hole 0 twice, hole 1 twice, hole 2, until I track him down. And I want to know how many guesses that is, right? So let's keep track of that. I'll just do plus I. I'll add a semicolon just for good form. I've probably got half of a dozen missing semicolons in here. All right, guess 44, guess 45. I guess I don't need to know because I looked in hole 49. So I'm always going to track him down below. Now I was thinking at first, my first thoughts along this line was I'm going to start in hole 50, right? Remember the hot or cold, higher or lower guess. I thought I would try and go from 50 up to 100 and then back down. Excuse me, major yawn there. Anyway, I thought I'd start there, but right, he could. Worst case scenario, then, if I go 50 to 100 and he's above 50, I've got a chance of finding him, right? I have a 50-50 chance of finding him within 50 turns, right? If I start at 50 and go either up or down, I've either cornered him or I've completely missed him. But the problem is, if he's on the other side, well, he might be following you, right? I might go 50, 51, up to 99, and he's at 98. Do I go back down? Or maybe he's at 0. I could lose him. So I guess best case scenario, or 50-50 chance of finding him in less than 50 moves. Or, worst case scenario, I go up 50, and I either go back down or I start at the top, start at the beginning again, right? So it'll be 150 tries to get him is the worst case. The trade-off for whether or not by dividing it like that, I can find him more. I don't know statistically. I don't want to try and think about that right now. So maybe that would yield. I think the answer is half the time it'll yield better, right? 150 plus 150, meaning half the time it takes 150, or 150 plus 50 is 200 divided by 2 is 100. So I think statistically it's about the same, right? If it takes me worst case 50 plus worst case 150 over 2 tries, that's 200 over 200 tries over 2 cycles, then that's 1 in 100. As opposed to just starting at 0 and marching my way up to 99, that's 100 as well. So I think it's statistically irrelevant where I start, because he could be either place and it doesn't matter. So I think this is the solution here. I'm going to run this a few more times just to see. Down the rabbit hole, I found the rabbit. I want to see if I actually go through in 100 tries and not looking. And I don't need to have the count here, the guess number, that because I'm starting at 0 and going to the end. So you looked in hole 34, rabbit moved to 41, so I guess what I want to do is, yeah, my counter's there. I just didn't see it. You started in hole 0. Right, 21. Yeah, and it'll always be 200. Actually, I guess, yeah, it'll be 200 tries. I had my numbers off earlier, right? It's best case on the flip would be 100 tries, 50 to 100, because I have to check in every hole twice, and then another 200. But the numbers work out the same for the same odds. So here's my scenario. The fun part was really building the test harness, right? I've got my random function that allows me to place the rabbit and then move him left or right. Once I've got that down, it becomes really clear how to look for it, look in the rabbit hole, and then just cycle through each time. And then it stops whenever I find him instead of continuing on. So this was a pretty fun coding challenge, but again, it's one of those brain teasers, right? Unless you know how to do it. I guess if you know search algorithms, right? Maybe this is one of those, if you've read the Crack the Coding interview and memorized all the algorithmic things that they ask in those Google code type questions, then you'll get it. But the hint there about, well, is it even or odd? That was the one that really sent me down the hole down the rabbit hole of, here's how I can solve it. This is probably not the best case scenario, but it's a simple scenario. And like I said, building the harness that tests my theory was the really fun part. And I hope you enjoy it as well.